Okay, so I'm going to go through the answers for section B. So I have the question on the left side and the answers on the right hand side. So I'm just going to run through it quickly. Okay, so let's start. So let's go on to section B, question 1. Okay, so let's start the thing. Let me go and out. Okay, so blue color. Drawing blue color. Oops. Okay, so let's start. So first one, which substance made of atoms that have a complete octet structure? So complete octet structure means that it should be a noble gas. Okay, and atoms only, right? So key idea here is that you need to make sure that noble gas, they are low melting boiling point. Okay, so anyway, yeah, so key idea is noble gas. So the answer would be P. So the answer would be P. Well, P is here. Okay, key idea because noble gas, so it has low melting boiling point and it doesn't react with oxygen because it already has complete octet structure, so it is already stable. Okay, stable and does not react. So the first one for part A is P. It has low melting boiling point and does not react with oxygen. Next one, B. Which substance is likely to be graphite? So graphite has your macromolecular structure. Macromolecular. So macromolecular structure generally, it has high melting boiling point. Okay, and because graphite, that each carbon is bonded to 3 others instead of 4. Okay, compared to your diamond. So that's why it will also be able to conduct electricity in solid state. So actually the answer will be U. Okay, so this is for P, this is for U, explanation is over here. So high melting boiling point conducts electricity in the solid state only. Okay, so you need to know graphite well. C, name the bonding present in substance Q. So substance Q, if you look at it carefully, the melting boiling point relatively high, cannot conduct electricity in solid, but molten state can. So most probably you look at this property here, it's a compound. It's a what kind of compound? Ionic compound. So what kind of bonding? Answer will be ionic. Okay, and why does it conduct electricity in molten but not in solid state? So this one is actually your basic ionic bonding, the electrical conductivity. So it has no mobile ions, because the ions are held in fixed position. Okay, ions held in fixed position. Whereas in the molten state, the mobile ions can act. The ions are free to move and they can act as charge carriers. So C, okay, this will be over here. Okay, let's go next one. Substance S is a non-metal. Okay, so you go back, substance S. What you have here for substance S, actually substance S quite a low melting boiling point. They cannot conduct electricity in molten or solid state. Ignites even at room temperature. Now, those of you who see the ignite at room temperature, then you're like taken aback, generally, what's the property of non-metals? Okay, low melting boiling point, does not conduct electricity in any state. So this one under your element compound mixture, okay, under the part where they talk about metals and non-metals. So R is a metal, okay, because high melting boiling point conduct electricity in solid as well as molten state. So this is the property, okay, that you need to just take note of. So justifying here, this is the answers. So this 2 is actually from the ECM, element compound mixture. Okay, so take note of that. Okay, next, question 2. Now for question 2, let's complete the table. So the formula, we have potassium 1939 plus, O816 2 minus. So key idea here is that you need to know that the plus and the minus only affects the electrons. It doesn't affect the neutrons and the protons. So this one is simple. Number of protons is 19, and this one 20. 20. This one, number of protons is the smaller number at the in the given here, which is the atomic number. Then number of neutrons, just take the top number minus 1. The mass number, you have proton number, you have it here. Now, number of electrons, if it's a plus, means it has lost 1 electrons. So this one will be 19 minus 18, so you get 18. sorry, 19 minus 1, so you got 18. This one 2 minus means it has plus 2 electrons, so this is 10. So 2 marks, 1 mark for per correct row. Okay, quite a simple answer, so a simple question on your atomic structure and your chemical bonding. Okay, next. 100 atoms of potassium, there are 94 of K19, 6 atoms of K41. So these two are isotopes. So what exactly are isotopes? Okay, so this one, why are these two forms are isotopes? It's actually your definition type of question. Okay, so the answer is they have same number of protons, which means that they're same element, and electrons, okay, but different number of neutrons. So you need you to take note of this. This is actually just a definition question, not very difficult, but most people always forget about definition. Okay, next. Find the total mass of 100 atoms of potassium, hence find the average mass of one atom. So this is actually finding the relative atomic mass. Now, normally what you're going to have is the percentage of each isotope. But now they didn't give percentage, they give 94 and 6 out of 100. You realize this is actually percentage also. It's actually 94% of K39, 6% of K41. How do I know? Can you see 100 atoms, 94? 100 atoms, I only got 6. So it's actually 94 and 6. So therefore, what you're going to have is, okay, so this is one way, so 39 times, okay, this is one way of doing it. The other way is, you take 94 over 100, because this is a percentage, multiplied by 39, plus 6 over 100, multiplied by 41. And if you do this, you'll still get the same answer of 39.1. Okay, so just take note, these two answers are actually exactly the same. It's just that I include the 100 into here. This one, they add out the total mass, then divide by 100. Okay, so both are fine. Both are the same. Okay, now let's go on to question 3. Question 3, tritium is an isotope of hydrogen. So once again, on the isotope again, an ion of tritium. So this is an ion. Okay, has the following structure. Complete the following table. So this is your neutron, proton, electron. Now, how do I know that? So plus and minus is a giveaway. Plus is proton, minus is electron. This blue one, or this shaded one in the middle, okay, actually is in the nucleus. It is not a proton, so it has to be a neutron. So charge is 0, plus 1, and minus 1. Using the symbol T to represent tritium, give the formula of the ion form. So this tritium ion, okay, how do I know whether it's plus or minus? Very simple. Look at how many minus charge I have, how many plus. So you realize that there's 2 minus charge, but there's only 1 plus charge. So if I look at it overall, what I'm going to get is a 1 minus. So therefore, the symbol T to give the formula of the ion, so it's T minus. And because it's a T minus, so think of it as it's like an ion, okay, with a single minus charge. So the compound form between sodium will actually be a Na plus and a T minus. You do your crossover, so what you're going to get is a NaT. Okay, so now just one more thing to add. Actually, this is quite similar to a hydride ion, except that this is for hydrogen, which is a 1-1. Okay, but this one actually tritium actually is a H3-1. Why I would put 3? Okay, you can figure out. So we're going to understand this. What's the difference between H11 and the H31? There's actually a deuterium, which is H21. So go and understand what's the difference between these 3. And you will realize that actually the minus and the plus here doesn't affect whether it's a deuterium, whether it's a tritium, or whether it's purely hydrogen. Okay, next. Let's go on to question 4. Now for question 4, salts can be prepared by various methods. Write down the formula of the salt that can be best prepared and write down the prepared salt name. So now, this one for 4a, okay, this is sodium chloride, because titration generally is for any sparse salts. So sparse salt means you sodium, potassium, or ammonium with either your nitrate, chloride, or sulfate. So there are many possibilities for the answers over here. So as I give me any sparse salts, that'll be fine. And what's the equation that I'm looking at? Actually, we need to give me the alkali with the acid. Okay, so do mark accordingly. Okay, if you have any questions for this, please feel free to just drop me a text okay, to check whether the answers are correct. But I think yours should be quite okay. Part B, precipitation. Formula of the salts. There's only 5 salts in your syllabus that you can use for precipitation. Okay, because the 5 salts, as I already told you all to go and remember them. Okay, so you got 2 chlorides. What are the 2 chlorides? Because the one you want the formula, right? So you got PbCl2. That's one of them, lead chloride. You got AgCl, this silver chloride. So these are the 2 chlorides that you can put as a formula. Sulfates, you have 3 of them. One is PbSO4, lead sulfate. The other one is BaSO4, barium sulfate. And the last one is calcium sulfate, CaSO4. So these are the 5 possible ones that you can put as a formula. Okay, and then the chemical equation. This one. If you have any questions, feel free to text me. I can double check for you. Okay, this is just for the barium one. You can actually swap the word barium for lead, for or for calcium nitrate. Then the acid can either be HCl, okay, or H2SO4. Okay, because forming chloride, forming sulfate. Okay, next one. Part C. One more method is used to add excess insoluble solid to an acid. Show how zinc chloride can be prepared. Now, acid with insoluble solid, right, actually is acid plus insoluble MCB. B can be split into either oxide or hydroxide, so MCOH. So therefore, if I look at this here, the 4 equations is actually metal, carbonate, so this is the M, this is the C, this is the O, this is the H. So because I need zinc chloride, so therefore all the acids are hydrochloric acid. Then the MCOH, okay, metal, carbonate, oxide or hydroxide. Then the product will vary, will change according to what's the main reaction. So metal plus acid only give you hydrogen plus salt. Metal plus carbonate, which is the 4th one over here, you will get the salt, the water plus the carbon dioxide. Whereas oxide and hydroxide, they are considered base, so it's just a salt plus water, salt plus water. Okay, so that's for part C. Now let's go on to question 5. Okay, question 5A, element and compound. Okay, so the website uses, okay, so there's this is information from a website about common salt. The common salt that we're talking here is sodium chloride. Okay, so you can read through the description, but the key idea is that they're describing about sodium chloride, bonding, the kind of arrangement and things like this. Okay, now please make sure you read through, don't just skip, must make sure you read through. Okay, part A. The website uses the words elements and compounds. Explain what this words means. So this is actually just a pure definition question, so 1 mark for each of them. So these 2 you can find from your textbook, so I'm not going to go through it. What I'm going to go through is really for part B here. So for part B, you have to talk about very hard. Next one, about regular shape. So this actually has to do a little bit of your bonding, plus also a little bit of your kinetic particle theory. So this regular shape part is actually from the kinetic, so kinetic particle theory. Okay, so first part, let's go for the very hard part. So generally it's very hard, okay, because the ions are held strongly together. So first thing, giant lattice structure, because that's ionic compound type of structure. Okay, so they are held tightly because of the oppositely charged ions attract one another strongly. Or you can say that because there's strong electrostatic force of attraction. Strong electrostatic force of attraction between the oppositely charged ions. Between oppositely charged ions. Okay, so once you give me that, hence you can conclude that for the crystals the crystals are very hard. So the strong force of attraction make it difficult to separate the ions, and hence they are very hard. Next one, okay, regular shape means that the particles are held in place, right? Why are they held in place? Because the ionic bonds are strong So they are held in place. Okay, so regular shapes generally tells you that, why do they have a fixed shape? Okay, why do they have fixed shape? Because they're held in place. Generally, I remember the ions are held in place by the strong ionic bonds. So they are packed in a regular and repeating pattern. Now, but generally, if you tell me that about these strong ionic bonds, that they are held in place, I think we can start to give you that mark already. Okay, but you need to conclude it, right? So that's why ions are held, regular and repeating pattern. Now the repeating pattern, if you didn't write it, I think it's fine. Okay, but the key idea here is because they're held in place, they give a regular shape. Okay, they give a regular shape. So just take note of that. Okay, next. Question 6. So question 6 over here, okay, empirical formula. So do remember, every time you got empirical formula, always have the table here. So this is CFC contains carbon, chlorine, and fluorine. So carbon, fluorine, and chlorine. Okay, or the other way around, whichever it is. Okay, then it has the following composition: 8.7, 13.8, and 77.5. So calculate empirical formula. So empirical formula, first thing, percentage, then AR. Then the mole, actually what you do is actually the percentage divided by the AR. But once you take the percentage divided by AR, you get the relative percentage of the mole ratio. Then generally you always, from this step to this step, you divide it by the lowest number. Okay, just nice, this one is 1, 1.002, 3.001, so you know the ratio, actual ratio is 1:1:3. So answer is CFCl3. Okay. Then the next question is, what's the maximum mass? Okay, so they say CFC12 has a formula of CF2Cl2. Now I need you to look at it. CFC11 is CFCl3. CFC12 is CF2Cl2. Okay, can be made by reaction of hydrogen fluoride with tetrachloromethane. So what's the maximum mass of CFC12 that can be made from 10 grams of hydrogen fluoride? Now, you see, for this kind of thing, right, generally most of you will think, I don't have reaction hall. But what you know is this, hydrogen fluoride consists of one F. It consists of one F, CFC totally no F. So to make it into CFC12, I know that one CCl4 must react with, right? Must react with 2 HF. So this is the ratio I need, because you see, I need to have 2 fluorines inside there. So 1 HF can only give me 1 fluorine. So if I want CF2Cl2, I'll need 2 HF because I need to put 2 fluorines inside here. So therefore, actually, that's why you know that the ratio over here is 2:1. So what they did was to first find the mole of HF in 10 grams. Once you know the mole of HF in 10 grams, so take note this 10 divided by 1 plus 19. 1 plus 19 is actually the MR of HF. Okay? Once you know that there's 0.5 mole of HF, you know that because the ratio is 2:1, right? So you know that there is only 0.25 mole of CF2Cl2. Okay? In terms of the maximum amount of CF2Cl2 that I can form is actually only 0.25. So once I know there's 0.025 mole of CF2Cl2, the mass will just be the mole multiplied by this is actually the MR of CF2Cl2, and I'm going to get 30.3 grams. Okay, so take note of that. Question 7. Okay, question 7 is another mole question. Okay, I got 6.72 grams of metal chloride, and it contains 1.42 grams of chlorine. Calculate the number of moles of chlorine ions in the sample. Okay, hence suggest a value for the relative atomic mass of M. So I need to find the relative atomic mass of M. So if I can find the MR of MCl, if I find the MR of MCl, and I can subtract this by the AR of Cl, okay, then I can get the AR of M. So the key idea here is that I got the AR of Cl, easily I can find it in the periodic table. The AR of M is a question mark, because I don't even know what M is. Can I find the MR of MCl? Actually, I can. If I have this triangle, so MR, mole, mass. I got a mass of metal chloride. If I can find the mole of metal chloride, I can find the MR. So how can I find the mole of MCl? I know that 1 Cl will give me 1 MCl. Correct? Because MCl, can you see? If I got 1 Cl, means obviously I will have 1 MCl. So let's find the mole of so let's first start off by finding the mole of Cl atoms. So I take 1.42 divided by 35.5, I get 0.04. So I know that the mole of Cl is 0.04. Okay. And because of the formula, I know that 1m, we get 1 Cl, right? So 1 to 1. So the mole of m is also 0.04. So the mass of m in the whole thing here, okay, it's actually 6.72 minus 1.42, I'll get 5.3. Because why? 6.72 of metal chloride contains 1.42. If I take this, subtract by this, I get 5.3 gram, which is actually the mass of m. So when I got a mass of m, I got a mole of m, you realize I can find the MR of m. Okay, I can find the MR of m. Okay, sorry, not MR, AR of m. So I find the AR of m, how to find? So I take the AR of m, right, take the mass divided by moles, so 5.3 divided by 0.04, I get 132.5. I'll round out the answer to 133 because of 3SF. Okay, so in actual fact, okay, this one will actually be good enough also. Okay, and any questions for this, feel free to text me. So instead of the MR, actually the question uses mass of MCl minus the mass of Cl to find the mass of M, and then from there divide by number of moles to get the MR. Okay, or I should say to find the AR. Okay, next one, question 8. Question 8 is on the idea of oxides. Okay, oxides. So carbon dioxide, CO2, because it's a non-metal oxide, it is not no cold water, so therefore it's acidic oxide. Neutral oxide, element with carbon. So obviously carbon and oxygen, carbon with, imagine you form of oxide with carbon. There's only carbon dioxide, and the other one is a neutral oxide, carbon monoxide. Formula, CO. Okay. Last one, chromium 3 oxide. Most of you say, how do I know what the oxide this is? Because this is a metal oxide. Chromium, if you look at your periodic table, is a metal. So this is a metal oxide. Generally, metal oxides, okay, you will get your basic oxide. The 3 here tells you that the chromium has a charge of 3. Oxide, you know, is O2 minus. So you do your crisscross, what you're going to get is Cr2O3. Okay, so that's for until question 8. I will not go through anymore, right? Because this is the end of section B, and that's all you need to do until for today. Most of you will spend a lot of time trying to think through how to go about answering the questions. Okay, so please make sure that you are clear on what to do. Okay, so that's all.